Okay, so they have started about your area between two curves in the class.
I wasn't in class yet, but yes, they've started that.
Okay. Give me a second, I'll share. Okay, so let it get opened. In the meantime, I'll just give the introduction of the given things. See, when I'm going to have a simple parabola or a rectangle or whatever it is. So finding the area is very simple. Even a single curve is there, you would have studied that Riemann sum, left Riemann sum, right Riemann sum, you will use, yes, to make it up. Okay, but if I are giving two curves, one line and one parabola, everything, and how to find the area between those features, so we are going to see that. Okay, fine, George? Yeah, it's open. Anyways, okay, just a second, I'm sharing my screen. Yeah. Just let me know once you are able to see my screen, George.
I'll see it.
Yes. So the biggest area between curves. Suppose a one single curve is there. What you will do? There is no specific thing how we can do it. Like if it's a rectangle, you have a formula for that for finding the area. If it's any of the polygon, you have a formula for finding it, right? But for a curve, what we introduced the concept before, the Riemann sum. We will split the curves into small rectangles, and we will start finding the areas of small rectangles and sum up to get the values. Yes. Yes, George, this you would have studied before. Now, just give me a quick second. Now, suppose if I'm going to have this, the previous one was only one single curve. Suppose if I'm going to have two curves, that is f and g. Okay, so I'm going to consider two curves, f of x and g of x, are continuous over the closed interval a, and g of x is less than or equal to f of x. Then the area of the region bounded by the graphs of f and g, okay, and the vertical lines. Okay, so that means this will give you the limits of the region. This integration from a to f of x minus g of x times. Understood, George? Yes. The main thing you have to note down is, suppose you are going to integrate with respect to x values, you have to consider one, because we have a two curves, right? But you will get a doubt which one I need to take first and which one I need to take next. If the integration is with respect to dx, okay, you have to take top minus the bottom. Understood, George? Always whichever curve is top minus the bottom times dx. Got it? Yes. And the limits will be from suppose if the integration is with respect to d1, it will be integration of d, okay, right minus the, okay. This order you have to follow it to get the perfect answer. Got it, George? Yes, understood? Okay. So how we are going to proceed this? I'll just show you through an example. Suppose if this is the question, okay? I have y equal to x squared plus 1 and y equal to x. These are the two curves I have. Okay, got it, George? Now, see, some questions they will provide you with the limits. Okay, that is x equals to 0, x equals to 1, like that. Some problem, you need to just calculate it from the graph. See, when you can graph it, you can see the region, whichever it is, getting shaded out, right? So 0 to 2 will be mine. Understood, George? And integration is about x-axis. If it is coming, means you have to integrate with respect to dx. So it's top minus the bottom. So top is what? Which curve is at the top? Y equal to x squared plus 1. That's what they are. Minus the bottom. Bottom curve is at x. Understood, George? Then this is like the normal integration we are going to do. Okay. So what you can do here is Just integrate this. This will be x cubed divided by 3 plus x minus x squared divided by 2. And you will apply the limit and give the answers. And you have to give the answers in square units because we are finding the area. Understood, Josh? Because they expect this. You got it now? Yes?
Yep.
Okay. So, in short, if I can say, another way is like you can just split the curves into small rectangles and make it. But in AP, they consider this method as a first method. Okay? Because this is the base. After this, you will be having the disk method, Gaussian method, slicing, everything. That this one is a so you can use this method. Okay. So what are the steps you have to follow for finding the area between the curves? The first step I'll say is just see to that they have given draw the picture. But I would say see to that whether the integration is with respect to dx or dy. Okay. So if they are given x-axis means you will integrate it with respect to dx. Got it, Josh? Otherwise, if they are giving y-axis means you will integrate it with respect to dy. Why I'm saying this is for drawing the picture also you should decide this two things, because if it is with respect to dy, I'll show you down. They will give you y equal to x squared. But about the y-axis they give, okay, Josh, you need to find what is x equals to. Got it? You have to convert it and then find it out. Otherwise, before doing that, if you're doing, then it is like you will make mistake. Okay. So first thing you will find that. Then you will start drawing the picture. You can take some table of it. Okay. And in the when you have the graphic, you will get your small region in that. Okay. So I mean the graphic region, the area you now after the shading part is over, you just take the rectangular strip. Okay. So that's very important. Anywhere in the graph you can take a small portion where the height is nothing but f of x minus g of x and the width is nothing but the dx always. Okay. Got it, George? Because we are going to take a rectangular strip. What is the formula for area of rectangle? Length times the width. Correct? Here the length is nothing but the height of the strip we are taking. The width is nothing but dx. Understood? And the height, how can you find f of x minus g? That's what they have to do. You understood? So the area of the region, integration from a to b, f of x minus g of x times dx. Now, after framing all these things, keep it in mind if it's with respect to dx, it's top minus the bottom. With respect to dy means it's right minus the left. Okay? And the value you are taking for the limits, a will be the smallest x value, b will be the largest x value. And the vice versa will be following for with respect to dy. Got it, George? Yes?
Just give 1 second. Can you scroll back up?
Yeah, yes.
Okay, got it. Thanks.
Yeah, sure. Okay. So, and this is your formula. You can make a note of it always. This is your formula and keep that in mind with respect to dy means it's top minus the bottom times dx. Okay. If you want, I will send this notes to you. Okay.
Okay. But I got it though.
Yeah, yes. Okay. Now, let me move on to the example problem. Okay. See this graph. They have given f of x is a to the power of x, g of x is x, and the vertical lines x equal to 0 and x equal to 1. This is the limit. Okay. Keep that in mind. Good. This will tell you about either it will be about x-axis, y-axis, or they will give the limit. For this problem, they have given the limits itself. So obviously, you can guess that okay, the limits are with respect to x means integration is also with respect to x. Got it, George? Now, what I told you, first step we have decided that. Second step, you graph it. You take some x and y coordinates, the table of values, just graph it. Okay. Now, let me come to the area. What I told you about the area, we are taking a small portion of that. It is length times the width. Here, length is nothing but the height times the width. So, width is nothing but x. What about the height? Top minus the width. When you see the graph of this, the top portion is nothing but e to the power of x. And the bottom portion is nothing but x. Understood, George? That I have placed in the formula. So, integration from a to b, f of x minus g of x times dx. This is what I have done. Okay. Just see to that, whatever your teacher is saying, the steps, what you need to follow, just do that, because in AP exam, they expect the steps more. Okay, step marks are allotted. Okay, Josh. Now, after this, just an integration, normal integration, you do e to the power of x integration is e to the power of x. And x integration is x upon x squared upon 2. Then you are applying the limit to find that. Got it? The main concept, two things you have to always remember: integrate it with respect to dx or dy, and it's if it is with the dx, top minus the bottom, dy, right minus the left. Okay, and finding the limits, that also holds the part. Okay, if you are allowed with the graphing calculator, then it's very easy. Just you can put out so that you will get the graph of that, and you can confirm the limits of that. Understood, Josh? Got it? Okay. Next question. Find the area of the region enclosed by the function C. There are two curves here. Previously, it was one curve and one line was there. Now there are two curves. Okay. Now they have not given any limits for this stretch. This is the second type of model you can expect. The first type you had the limit; they are already given. In the second type, we are saying a question without the limits. This one, you can either guess it from the graph, or otherwise, you can check your answer like this. See, the region after graphing, you will get it out, okay, what you are getting. Okay, wherever this point of intersection, that will be. Otherwise, what you do, when you say that take the two graphs, the left hand sides are equal. Am I correct? So equate the right hand side. Understood, George? Got it? What I'm trying to say?
Can you say one more time? Sorry.
So I'm saying, see, previously they have given the limits for us. Okay, x equals to 0, x equals to 1. For this problem, the limits are not given for us. Okay, we need to find it. When you graph it, do we get the wherever the two, I mean the curves intersect, that point of intersection, the x coordinate will be your limits. Okay, by the graph also you can find. Otherwise, what you can do is you can check your answer, whatever you what is the limits are correct or wrong. That is, what you do is, see, you just take it when you see the two f of x and g of x, got it? Just equate the right hand side. Understood, Josh? Now take this x squared to the side. 2x squared would be equal to 2 times x. Understood, Josh? 2 gets cancelled. I'll be left with x squared equals to x. Now bring this to this side. X squared minus x equals to 0. Factorize this x outside. It's x times x minus 1 equals to 0. You have in a quadratic formula that if a times b equals to 0, then a equals to 0 or b equals to 0. Correct? So these are this is one of the way you can just check your answer. Mr. Josh, got it? So don't get confused when you can just check your answer like this also. So it's top minus the bottom and doing just the area of the slicing, integration from 0 to 1. We are just applying and getting it. Got it now? Yes?
Yep.
Now let me move on to the next one. Now see this. Here also the same thing. If you have your graphing calculator, it's very much good. Okay. So for this also, they have not specified what are the limits here. Okay, George? So what I will do is I will graph it out. Okay, wherever is the point of intersection of this will be 0, 0. Okay, and the point of intersection for this after graphing, they are getting this point. Okay, now as I've already told you, we have to take only the x coordinate. Okay, that's why it is 0 to 1.1. Okay, and what does it with respect to dx? So it's top minus the bottom. So what you will do here, top portion is this one, right? X over square root of square plus minus of this one. Understood, George? Now the normal integration, we are going to do this and so on. Okay, the integration and all becomes simple. Only the thing you have to, the framing the formula is very important and you should not make mistake. Okay, understood, George? Fine. Okay, the next problem. Now see to this. Now This is also of the same type, but see the difference. Find the area of the region in the first quadrant. See, first quadrant they've already given. Bounded by y equal to square root of x, y equal to 0, y equal to x minus 2. So I'm going to split out into two regions. Okay, fine. So because I'm having the curves like that. So the first region, because I'm not able to find what is the limits. I'm going to make it out into two regions. That is, the height will be nothing but what I told you. It's the top minus the bottom. Okay, here, the top one will be square root of x, and the bottom is 0. Okay, and similarly, top minus the bottom for the region. Understood, George? You got my point? Then we are just splitting the areas and making it out. You can ask me a question why I cannot combine. You can combine or so and do it. Good work. Okay. Understood? This is the third type of model. Next type is in terms of your y. Is integration with respect to y. Okay. This is the formula we use it for integration with respect to dy. Understood, George? So area will be nothing but f of y minus d of y. This is like right minus the left times dy, where c is the smallest y value and d is the largest. Understood, George? Right. Okay. Now, the next, I will show you an example so you will understand. Area of the region in the first quadrant by the graphs of the C. This is what I told you. They will give you x equals to y squared in some cases. Some cases they will give you y equal to x squared, but about the y-axis they will give. So in that case, you have to recognize that we have to integrate with respect to dy, and you have to change the function in terms of your x. Okay. Now, what I will do here is they have given x equals to y squared. Okay. This is what they have given to us, y plus 2, and y equal to 0 is 9. Okay, Josh. Now, as I've already told you with respect to dy, it's right minus the left. So it's y plus 2 minus y squared it is. Okay. So the area will be nothing but f of x, so f of y minus g of y. Smallest y value, and this one is the largest y value. I have to take it from the graph. Okay. Otherwise, what we do, y squared equals to y plus 2. You can just guess it from this one also. Okay, Josh? Y squared minus y minus 2 equals to 0. This is a quadratic equation. When you solve, you will get these two. Understood, Josh? Okay. That way also you can count your limits. Okay. Next. Let me make this. Now coming to this, you need to find the area of the region enclosed by the graphs y equals to, okay. So in this case, what you have to do. So now the two graphs are there. Again, we are not having any point of intersection here. I mean, the limits of not given to us. Okay. So when you see the graph, it's like when framed itself, it is like having towards the y-axis. Okay, Josh. So one thing that you need to change this one in terms of your y. This y equals to x cubed. You have to change it in terms of your x. So there is the cube root of your y. Understood, Josh? Okay. The cube root of y minus of it's y squared minus 2 that we have. So the area will be nothing but it is again you will be having right minus the left. Okay. That we are framing it out, and the limits are the point of intersection. If you use a graphing calculator, you will get perfect values. Okay. Either just doing from this, if you have a graphing calculator. If not, also just take an approximate one, at least one decimal point. Okay. A final answer, it won't differ much. You will get it out. Okay. Just let me move it down. Okay. Now say this problem. Let R be the region enclosed by the graph of this f of x they have given, and the horizontal line y equal to 4. The vertical line at x equals to k divides the region into two regions, okay, with equal areas, right? But not solved. So there is no need of solving this. Just we need to frame the formula, okay, involving the integral. Fine. Now, first thing we have to guess whether it is with respect to dx or When you see the line, the vertical line x equals to k divides the region into two equal areas. So obviously, with respect to get, we are going to do it. Understood, George? Now, this is also all the functions are with respect to x. So first to curve and just graphing. Y equal to 4. Okay, George? Now, I'm not having this. What is this region I'm not having? This is only splitting these two regions into two equal parts. X equals to k divides the region into two equal parts. So what I will do is 0 to k, I'm going to keep it as it is and then integrate. Okay, so it's top minus the bottom I will have. So what is the top one? I'm having y equal to 4 is the top minus the bottom one and writing it. Since I'm not having the exact limit here, I'm not going to substitute. Just, I'm not going to solve it. I'm just going to substitute it. Understood, George? Yes. Okay. Shall we do some problems on this? Shall we try some problems? Yeah. Okay. Just give me a quick second. Yeah. Okay. Just give me a quick second. I'll open it here so that we can write it. So just go through all the 80 papers, how much ever possible, just try to solve it. And main thing, whatever methods they expect, that should be there. Okay, just say one question paper solving or something they have done. I mean, I'm saying that what you will say, the stepwise calculation, and in the next class, I'll try to show you that. Okay, so each step will be allotted mark. Though the school, they will teach you in some other way because the teacher differs, but there they expect something. Okay, fine, George. Here we go. Find the area of the region. This is the first one. F of x equals to x squared and g of x is negative x. You also calculate. I'll also try. So
is there a specific upper bound and lower bound, or
no? They have not given anything. So you are going to find the limit now. Either you graph it and find it out. Otherwise, use that right inside equal to 0 and make it up. Okay. Just try. If not, I'll do it on the white.
see in 1 second then.
Yeah, yes.
So I got negative 0.167.
Yes, good job. Okay, next. Number 2, y equal to x cubed, y equal to x squared. Okay.
Three x squared minus 4.
Okay, you are using a graphing calculator?
I'm just graphing it right now.
No, I'm asking you.
I mean, I don't have a calculator with me. I'm just using a software to graph it, but
Okay,
it's 3x squared minus 4, right?
Yeah, yes.
Okay.
I will just maximize the size. You are able to view the screen, right? Okay. Just be careful with the finding the limits or no. If you have any doubts, just equate the right hand side and try to find the value of x and check your answer whether it's right or wrong.
Just a quick second. Sorry.
Yeah, yes, George. No problem.
how would I do this one on number 2?
Okay, see what I have done is first graphing part, you can have the table of values, okay? Fine. So accordingly, if I graph, I'm getting for the y equal to x cubed, I'm having a curve like this which touches the origin and goes there. Okay. It's just touching like this and going. Okay. Okay. Fine, George. And for this one, I'm getting a parabola opening upward. Okay. So it's with respect to dx. When I see the graphics, I'm getting it out. Okay. So its area would be nothing but top minus the bottom. Fine. So top is nothing but x cubed minus the bottom. I'm getting it to be 3x squared minus. This is George. Fine. And I should have a bracket here, otherwise I'll make a mistake because they're negative signs. Now coming to your limit part, from the graph, I'm getting -1 to 2 is my graph. I mean points, but you can even check it.
1 to 2?
Yeah, -1 to 2. You can even check it like this, x cubed like this. Okay. Fine, George. That way also you can check it out. That also I'm getting it to be the same. Fine. Now,
Okay.
in that case, if you want, you can bring this to the right hand side. You can use a synthetic division. You know to solve a cubic equation, right? Using the synthetic division, yes, George? You know to solve that, right? Okay, fine. Okay, so now that's a normal integration I'm going to do. It's x to the power of 4 divided by 4 minus of, if negative sign will come inside 3x cubed upon 3, okay, plus 4x. Okay, and the limit I need to apply from -1 to 2. Understood, George? Fine. So if I apply the limits for this, it would be 4 to the power of 2 to the power of 4. Upper limit always minus the lower. Okay. Minus this 3 gets cancelled. It's 8 plus 8. Okay. Minus of, let me open a bracket. So this will be negative +1 upon 4 because -1 to the power of 4 minus this will be nothing but -1. This will be +1 here. Okay. Then this is -4. This is George. Got it? This and this gets cancelled. And 4 times 6 is 24. 6 will be there. And this, let me take the least common multiple here. This is 1 upon 4 minus 3. Okay. So 6 minus, so this is 12. 12 minus 1. So that is -11 upon 4. Okay. Now this will become positive here. Okay, Josh. So this is plus 11 upon 4. Okay. So when I take the least common multiple, 24 plus 11 divided by 4, that I'll be getting it to be 35. Okay. This is what I understood, George. Got it? Okay. Okay. Now let me move on to the next one. Okay. Can we try the problem number 3? They have given the graph also for you. Just take out the integration will be with respect to dx only. Okay, they have given the limits also for us. Just we need to substitute and make it up.
And sorry, just the limits
1 to 2
for 4. Oh wait, from for 4?
No, number 3 only you are doing, right?
Oh,
okay, no problem. You just continue with number 4. Even I have completed this. I will start with number 4. So just complete it. Yeah, no problem.
but can you find a shaded region for number 4 because it's not necessarily enclosed? It's just 2 lines intersecting.
Come again. What you're trying to ask?
For number 4, it's just 2 lines intersecting. Like it's not like one is entirely enclosed. So
you will be getting like this, right? One parabola like this, and sorry, towards your it will touch the This side it is coming. Am I correct? Yes, Josh. And a line is coming like this. Am I correct?
Oh, sorry. Yeah, I was doing something else. So yeah, I was doing something else. So
this is a very important topic from this disk
yeah,
motor washer, and definitely you will get a question from among this. Anyone should be there in your paper. I'm not sure about area between curves, but for sure disk or washer method or the shell method, you will definitely. Sometimes
okay, so just, oh, sorry. Yeah, sure. Just give me a second.
yeah, yes, calculate.
How would I put this into the into the equation? Because for x equals 2y squared, you get two values. You get plus or minus x over 2. So
See, in this case, either you use your graph, okay, for finding the point of intersection. Otherwise, you are not getting for that this one. 2y squared, because we are going to integrate it with respect to dy, correct? So you should keep
right.
x equal to, so y equals to y minus 1 we will have. So 2y squared minus y plus 1 equals to 0. Now try to find it out. Just solve this quadratic equation. Whatever limits of 2 you are getting, that will be the limit. Okay.
So it's 2y squared minus y plus 1.
Yes, just solve this. You will get your limits. If you're having your graphing calculator, it's well and good. You will get your answer in a few seconds. Otherwise, try to just see you have graphed the points by George. Wherever is the point of contact, you take that. I mean, this and this will intersect one single point, right? Then you can check with this method. That way also can take it. I have taken the vertical strip here. Email you can take it.
Wait, but it's not coming out to be so 2y squared minus y plus 1, and then y would equal, would you say that y equals 2y squared plus 1? So
it's negative y plus 1, George. It's a quadratic equation. So you take the factorization, we want to solve the quadratic equation, right? So it's 2 and negative 1. So 2 and negative 1 means I can take 2 and 1 for this, because 2 times 1 is 2. And negative 1 I should get. So I can go with that's fitting. So you have to use the you remember the quadratic formula, minus b plus or minus squared minus 4 times a times that method we have to use to check divided by 2a. Okay. So in that case, let's check for here. I got it from the graph.
But it would still be imaginary though.
Yeah, but we can just have an approximate value. Irrational, yeah. You can just go for the complex numbers, right? 1 plus or minus. So this is negative 7 I'm getting. So plus 4. So approximate you can say. You can just check your answer, I think, for this. I just use the graph for making it out. I just took the table of values, right? Wherever there's a point of intersection, I took that. I can show it on the whiteboard. Just give me a second. I just how I did. One. Let me share. See, our graph is x equals to 3y squared. Okay. X plus y equals to 1. Fine. Now you just take the x and y values. Okay, Josh. So I will take 0. Fine. Then you can have the decimals also you have it 0.5, Then you can have 1. Okay. Got it, George? I'm just checking the positive values. And then for this one, it is x will be equal to 1 minus 1. I think I made a mistake. It's not y minus 1, it's 1 minus y. That's why I was not getting it also. Okay, so now this if I solve, I think I'll get it, George. 1 minute. 2y squared will be equal to 1 minus y, or 2y squared plus y minus 1 equals to 0. Yes, George, I hope I will get that now. 1 minute. Negative 2 and positive 1. 2 times, yes, George, I'll get it out. Just give me a second. So I will have 2 times, oh, then also because I need to have a negative sign here also. Oops. In that case, if I solve it using this one, minus b plus or minus square root of b square minus 4 times a times c, right? Am I correct? Yeah, divided by 2 times a. Because I use the table of values, I got it. I didn't use this method. Okay, plus 8. I think we are getting it now, George. Negative 1 plus or minus square root of minus 3 divided by 4. Yes. Now, this is nothing but y would be equal to, okay, negative 1 plus 3. So that would be positive 2 upon 4. Yes. 1 upon 2. Yes, George, I'm getting, because I got the one of the coordinate to be 0.5. Okay, George? Okay, next I'll do it at this side. Y equal to negative 1 minus 3 upon 4. So it's negative 4 upon 4. Yes, these are the coordinates I got. Negative 1 to 0.5 is our limit. I think I made a mistake in taking this to the right hand side. This also you can just take it. X and Y coordinate, you take it. Okay. And then you just take some values, negative 1, 0, 1. Substitute your values, you will get the point of intersection. Understood, George? Got it? For both the things, 0.5 values will be same for this. You can check it out. You got it now? How we got it? You understood? Any doubts?
Yep.
Yeah. Any doubts?
For the most part, no.
Okay. So just try to, yeah.
Oh, sure. But one more thing too. There's also another lesson that was also
okay.
There too.
What is that?
Just give me a quick second. Area between two curves with respect to y.
That's what the down is. I have already taught you just now, right?
Yeah, I know that's I know. I was just like clarifying. That's all.
Yeah. First is with respect to dx, but second with respect to dy. Okay. That's we are going to do. The fifth problem is that one. Okay. Yeah. Okay. Just I have let me write the things. Just clarify my answer alone. So I will give the limits and everything for you. Just integrate and tell me the answer for this. Let's complete this problem and go to dy. Okay. So I got negative 1 to 0.5. Okay, it's 1 minus y minus 2y squared times. Can you integrate this and let me know the answer, George?
Sure.
Yeah, so that we can go to.
So you said from 0 to 5?
No, it's negative 1 to 0.5.
Negative 1.
Yeah.
Oh, 0.5. Okay, sorry.
Yeah.
In a second.
Yeah.
That should equal 1.125.
Yes. Okay, George. Come to the problem of now. Already you have seen for dx. Now the integration is with respect to dy, and it is a right minus the left is the root. Okay, got it? So let's try with problem number 5. So you need to integrate it with respect to dy, and the limits are from right minus the the function is right minus the left. Keep that in mind. Okay. is it, George? And the coordinates also smallest y value and the largest y value. Okay. You remember the formula, right?
For which function again? The formula for
5.
which?
Number 5.
Oh, number 5. Yes.
Yeah.
So it's the integration of of -1 to 0.5 of, in parentheses, 1 minus y minus 2y squared and in parentheses times dy.
-1 to, what is your limit you are getting? Sorry.
Oh, -1 to 0.5. -1 to 0.5.
No, already they have given the limits. You don't have to do anything with that.
So it was 1 minus y minus 2y squared.
Why, George? Which problem
No,
you're doing?
no.
Number 5 only you're doing, right?
Yeah, number 5. You told me to give you the equation which you just did, right?
This one you're doing, right?
Yeah.
So the integration will be -1 to 1. It is e to the power of y minus y squared minus 2. We are integrating with respect to dy, not with respect to your x. That's what they have given x equals to.
No, but then what was the first equation which you saw first earlier?
That is with
From
respect to dx.
That was with respect to dx?
Yeah. That's what I was saying from the starting, that just go through the function y equals to, if they are giving, then with respect to dx you have to integrate. That is about the x-axis is given, it's integration with respect to dx.
Okay. I wasn't in my class today. I was taking a test outside while the class was learning a different topic. But yeah, so but then for reference, what would that first equation from the integration of -1 to 0.5 of, in parentheses, 1 minus
that is problem
y.
number 4. This is problem
No,
number
4.
Yeah, that's what you completed and told me the answer also, no?
Oh, okay. Sorry.
Yeah.
Never mind.
Okay, come to number 5 and solve and check the answer. I have written the equation also.
Sure. So, and before I solve it, how would you arrive at where it would be e to the power of y minus y squared minus 2? How would you arrive at that? Would you just basically subtract ey and then?
No, I told you the formula, right, for you.
Oh, okay, never mind. I see. Because
the
it says
right
from
minus the left, you have
yeah,
to graph it out.
yes, because it's from -1 to 1, right? So I was getting confused.
Not
so
like that, not from that. After graphing the curve, if it is whichever is the right curve and from the left, that only. You are not seeing this one, -1 to 1, you are not seeing. Did you understand the thing which I taught you before?
No. Never mind. I was just I was just getting confused like with the.
I'm asking you that I showed you some notes, right? Did you understand that? How you are this?
No, that part I understood. It's just that.
Okay. See, for example, you take this. You just take this one. What you have to do here, this one, if I'm going to take, just graph it. From the graph, you have to distance with respect to dy, because the function is given as x equals. Okay. So definitely I'm going to integrate with respect to dy. Okay. So what I will do, first see the graph. It is like with respect to dy means right minus the left. With respect to dx means top minus the bottom. Now it's with respect to d. What is the right curve? Y plus 2 is the right hand side, right? Left hand side is y squared. So subtract it, you will get. Got it? Yes, George? Okay.
Yep.
Now come to this. Same way, when I graph, e to the power of y will be the right hand side, and this one will be on the left hand side. Okay. Can you just graph and see this first? Then you will get an idea. Just try this problem fully. I wanted you to graph it out. Then you go for the steps. Please take some table of values. Okay. Graph it out. Then substitute these and find that.
For
number 5.
Number 5.
Yeah.
Okay, just give me 1 second. Sorry.
Yeah. Today you are in a confused state. What happened?
No. Just it's not that I don't understand what's going on. It's just that I was just getting confused in which like what we were doing because
No, that's
the
what I'm
fourth
saying.
no, because the fourth equation we were solving for like under the space for number 5. That's why I was getting confused. And then
Oh, okay.
yeah, so just integrating that I got
Uh-huh.
5.684.
Yes, George. Okay. So the graphing part is very important, and there is a mark. Unless and until they give the graph, you have to graph it out. Otherwise, they will reduce the marks for that because from that graphing, that vertical strip you're taking right, that's very important there. Okay. Okay. Let's move on to this.
Wait. So just let me try it. So I already know that you have to basically write this equation twice. So in this case, just give me 1 second. Sorry. So minus 10x. Just give me 1 second. Sorry. I'll do this myself.
Yes. First graph it, you will get an okay. Graph is already given for us.
Yeah. Yeah, I'm just graphing just to make sure I know which graph is which.
Okay, sure.
And then the next graph is minus x squared. Wait, it's minus x squared plus 2x. Okay.
Yes.
So it's 3x cubed minus x squared minus 10x, and then negative x squared plus 2x. Okay.
Yes. Good.
So this is gonna. So then this is gonna happen twice. So in this case, you have to basically integrate this twice, then add the sums of those two integrations together.
Yes.
So first.
So, first
first, like what you would do is you would solve the integral or whatever the zero. The zero to the far right of what would be for 3x cubed minus x squared.
This one I took it as y2. Okay. So for the first region, it is that I'm getting negative 2 to 0. I will write it out. It's y1 minus y2. You have to do it. Okay, George. That's what I'm getting.
Is it from? Sorry. It's from 2, right?
Negative 2 to 0.
Negative 2. Got it.
Then from 0 to 2, I will have.
Yeah, 0 to 2. Again, and then you would reverse the order.
Yes, y2 minus y.
Yeah.
Now integrate and let me know the answer. That's all.
Yeah. It's just that I just needed to enter this in. Entering in is taking a painstaking amount of time.
Yes. Subtract it, just cancel it out, then substitute, integrate, and then give me that.
So the first one is 12.
Yes, very good.
And then the second one should just be 1 second.
Yeah.
The second one should just be, in this case, 12 too. So 24.
24 is answer.
Total.
Correct. That's it, George. You got it. Okay. Now I wanted you to try with this number 7.
Okay, I'll try this one quickly.
And the x-axis they have given, so we don't have the limits here. So obviously.
So then the x-axis would just basically be when y equals to 0, right?
Yes. That means you have to integrate it with respect to dx only here. Okay.
With respect to, so you would integrate it only with respect to dx, and that would be given if it was said like the x-axis.
Yeah, if that x-axis is coming, then you have to integrate it with respect to dx. If it is given y-axis, then obviously, because x-axis means you will put y equals to 0. Am I correct? One of the coordinate will be y equal to 0. Okay, so that's the thing, concept there. Okay, just draw the region, then you will get it out. What are the things you have to make it out? Because you will subtract this minus this. Yes, George, because you remember the height, right? You get 2 regions here. So it's x plus 2 minus 0 you will have. And another region you will have square root of 4 minus x minus. Okay. Just to make the region adjustment for the height. R1 and R2.
Then the x-axis. So then it would just be
time I have to make out the graph. 1 minute.
So how would you know which one would be the equation for the top and the equation from the bottom?
You have to graph it out. Without that,
Yeah,
we
but
cannot guess it out. We cannot guess it. Just take some table of values.
oh, right. I'm
Yeah.
sorry. I was
Yeah.
getting confused basically for a
Okay.
second.
So just take the table of
Um,
values and make it up.
do they want us to find a specific because there are two places
Not the specific, George. You just
so-
graph it out. You will get the point of intersection. That will tell you what to be. I mean, the area will come automatically when you graph it.
okay, so then the area of intersection, that would just be the area between two curves. That would be
Yes, because we have an and x-axis. So definitely you will get two regions that y equal to 0 will be coming in between. Okay, so I'm getting a line like this. Okay, for y equal to x plus 2, I'm getting here. Got it? And the curve is like going like this out.
yeah. Mhm.
So now
No,
it
but
is,
the curve doesn't continue though. It just ends at the x-axis.
yeah, I'm just saying for approximately. Okay.
Okay.
So this is 4. Okay, this part is edging. Okay, so now I have already split it. This is R1 and R2. I will split up. Now you need to frame your region. So that would be nothing but integration from -2 to 0 plus. This would be nothing but you will have it from 0 to 4. And now you can decide which is top and bottom. We have already done that. X plus top minus the bottom. That is, this one will be the bottom for this one. Okay. Yes, George. And for this one, it is like this is the top and this is the bottom. Again, we have frame. Understood, George? Fine.
Mhm.
So it's just integrate this and let me know that. X plus 2 times dx. And this would be square root of 4 minus x times dx.
And you would do those separately?
No, I have written, it's a total one I'm saying, the area to be.
Oh, so it's just the integration from -2
2
to
to 0. 2 to 0.
-2
0
to
to
0. Okay.
X plus 2 times dx plus integration from 0 to 4 square root of 4 minus x times dx.
So -2 to 0, x plus 2 dx.
Yeah.
And then looking over a second. So that's 2. And then from 0 to 2, just
0 to 4. 0 to 4.
0 to 4?
Yeah.
Right.
Square root of 4 minus x times dx.
That's 4 and then 5.33. So 7.3
Yes.
or
George.
7.34.
That's it. Okay.
Mm-hmm.
Understood, George? Okay. Now
Yep.
coming to your number 9, this is of the type where you remember that just we framed the equation and we didn't find anything. This type of question will also come where you have to find the value of k. Okay. So for this, you have to just graph the equation first. Okay. So one clue they have given here is y equal to square root.
Oh, can I try this on myself?
Yes, sure, for sure.
So when I say divide into regions of 2 equal area, what would that look like on a graph visually?
Like when I graph it, I'm getting like this. One will be a curve,
Yeah.
square root of x, and you will be having y equal to k. We doesn't know that. Sorry, yeah. And then one more 0 to x equals to 4 is one thing. Okay.
So then the first region would be equal to the area of the second region?
Yeah.
Okay.
So this is one region and this is one region. Okay.
So then the integration of R1 would have to equal the integration of R2.
See, whole area will be 0 to 4 square root of x minus 0 times dx. Okay.
Mm-hmm.
So we have to set up into 2. So you will have integration from 0 to k square root of x minus 0 times dx. Okay. Yes, Josh? Fine.
Mm-hmm.
Then you equate it to the things and get the value. You have to set your R1.
And then K.
Yeah.
Oh, equal to R1. And so then equal to R1. So then. Wait, what does that say on the bottom? 2 minus K?
I'm saying set your area of your R1 equal to half of the area of half of your whole area. First find what is the whole area. So this one, if I integrate.
So 0 to 4. So then.
It's a 16 upon 3 I'm getting. Okay. You just set up that equals to 8 upon 3. That is this one equals to 8 upon 3.
And then you just have to basically do the derivative of that. So
yes, that's it. Just find the derivative of this because integration and differentiation gets cancelled. So you can find the value.
And so finding the derivative of that, would you just do d over dx times how would you find the derivative of that?
See, this and this gets cancelled here. Okay, George? Mm-hmm. Fine, because integration and differentiation gets cancelled or if I differentiate it. So I'll be getting it would be x to the power of 3 upon 2 over divided by 3 upon 2 will come. Okay, I'm going to integrate it. So integration from 0 to k, it would be, this would be nothing but 8 upon 3. Okay.
And then
so 2 upon 3 will be equal to x to the power of 3 upon 2. And the limit is from 0 to k. Okay.
Okay, so then just give me one quick second. Then let me just try solving that. That's what I was thinking of. It's just that I wasn't really sure if that was the correct method to do it.
Okay. Just apply the limit and let me know that.
Mm-hmm. So then give me a second.
Mm-hmm.
Wait, sorry. I got 2.520.
Yes, correct. Okay.
Okay.
Fine, Josh. So I think this from 9th can we continue in the next class?